4.3, solve x squared plus bx plus c equals 0 by factoring. So this comment here is so perfect for today's lesson. It is just awesome. After you finish watching this video, I want you to come back to this slide and write a little response about how this makes sense and why it's actually so perfect for this lesson. And does this guy actually have any other roots? If he does, let me know. So please write that response on this first slide, and I'll look for that when you come into class. Let's begin with some key terms. A monomial term is just a number, a variable, or a product of numbers and or variables. So something like 5, 2x, even 5 times 2x. It's just a term, and those are monomial terms. A binomial term is a sum or difference of two monomials. So you probably didn't understand what I just said, but if I tell you a binomial is something like x plus 2 or 5x plus 7, that is just the sum or the difference of two monomials. So 5x is a monomial, 7 is a monomial, and the sum or difference of them is a binomial. A trinomial is the sum or difference of three monomial terms. So something like x squared plus 5x plus 6 would be a trinomial. You can use factoring to rewrite a trinomial as a product of binomials. So in this case right here, x squared plus 5x plus 6, we could factor it into x and x, maybe 3 and 2, plus and plus. The outer is 2x, the inner is 3x, that makes 5x. So this is a trinomial, and it can be written as a product of two binomials. Conversely, you could use FOIL to take the product of two binomials and make it into a trinomial, right? We could use FOIL to multiply out these two binomials and make it into a trinomial. So let's start by just factoring. So I always put my parentheses first, and then what makes x squared? Well, an x and an x. And then I try and think about, let's see, what makes 48? Well, 12 times 4, but that wouldn't make 14. So maybe 6. Let's see, if we put in 6, we get 8. So 8 and 6, yeah, that would be 14. So that would be fully factored. This one, let's see, if I have x and x, my only options for 5 are 5 and 1, but there's no way to make a 9. So this one is not factorable. The answer is no. If this was written as x squared minus 9x minus 5 equals 0, I would use the quadratic formula to solve. But I do not use a quadratic formula to factor. Let's just talk about the difference of two squares. If I have something of the form a squared minus b squared, I can factor it into a plus b times a minus b. Let me just explain that a little bit further. Let me start with some numbers. So if I have something like x squared minus 9, well, this is a perfect square, and 9 is a perfect square because it is 3 times 3. So this is x times x, and this is 3 times 3. So that means that I could factor it into x plus 3 and x minus 3. Whenever we have the difference of two squares, the reason that we don't have a middle term is because the outer which is in this case negative 3x, and the inner, which is positive 3x, cancel out. And that is the beauty of the difference of two squares. We also have perfect square trinomials. You don't need to memorize this at all, but if I have something like a plus b times a plus b, then that would be a squared plus ab plus ab, which is plus 2ab, plus b squared. And also I could have, if I had a minus b times a minus b, well, that would be a squared minus ab minus another ab is minus 2ab, and then the last is plus b squared. And an example of this would be something like x squared plus 8x plus 16. Well, if you identify that this first is a perfect square and this last is a perfect square, and then the middle is just 2 times one of those, well, that's a perfect square trinomial. But you don't need to memorize this because you can just think about it every time. Like, here it is, let's factor it, x and x, 4 and 4, oh yeah, plus 4x plus another 4x, yeah, that's 8x. And so that works. So I wouldn't even memorize these two, but if you ever hear the word perfect square trinomial, that's what it's talking about. And also, I just want to share with you my very perfect birthday. I was born on September 16th, and it's a very perfect birthday because that is 9/16, and 9 is a perfect number, and so is 16. So if I ever asked you to factor 9x squared minus 16, the difference of two squares, I would expect you to be able to do that problem without any difficulty. Since 9x squared is just 3x times 3x, and 16 is just 4 times 4, then that factors into 3x plus 4 and 3x minus 4. Please take special note that we only have the difference of two squares. This could not be a plus sign. If this was a plus sign, then it wouldn't work because my last term has to be negative in order for the outer and the inner to have opposite signs. So let's go ahead and factor. Well, clearly this is a perfect square and this is a perfect square. And so this just factors into x plus 11 and x minus 11. Again, my outer and my inner, I have minus 11x plus 11x. That sums up to 0x, and so that's why I have no middle term. In this one, I do recognize that this is 7 times 7. So let me try that out since I'm in this section. M times M, 7 and 7, so plus 7 plus 7. Yeah, that works. And then in this one, 144 is 12 times 12, and 12 and 12 is 24. So since this one is negative, I'm going to do minus and minus. You can also write these as like m plus 7, the quantity squared, or x minus 12, the quantity squared. I would accept either answer. Now let's do the zero product property, and we use this to find the roots of a quadratic equation. And I gave you a preview of this in yesterday's lesson. There's something very cool about if a times b equals 0. If a times b equals 0, then a has to equal 0 or b has to be equal to 0. And this is very special because only when I have two things multiplied together equaling 0 does one or the other have to be 0. And I cannot stress that enough. Only if it equals 0 are one of the factors necessarily 0. So, for example, if I have a times b equals 1, this does not mean a equals 1 or b equals 1. I do not necessarily know that that is true because I have so many different combinations that could work. I could have like a equals 6 and b equals 1/6. I could have an infinite number of things to make this true. only when I have two things multiplied together equaling 0 that I can say this equals 0 or this equals 0. This is so crucial. Do not ever forget it. So for an example, if I had something like x plus 5 times x plus 2 equals 0, then that means that either this factor equals 0 or this factor equals 0. So either the x plus 5 equals 0 or the x plus 2 equals 0. And then I could solve it. So I would subtract 5, x equals negative 5, or x equals negative 2. I call these the roots of my equation. Another word for roots is your zeros. And I actually like the word zeros a bit better because the zeros just mean, if I'm graphing a quadratic equation, it's where the parabola hits the x-axis. And I'm wondering right now if you can make sense of that. I'm not going to get into it on this lesson, but a little bit of a hint, if you want to think about it right now, is if I have something like y equals x squared plus 7x plus 10, and I wanted to find the zeros, wouldn't I be just making y equal to 0 to find the zeros? And when I make y equals 0, isn't that saying the same thing as finding the x-intercepts? Boom, that all goes together. If you didn't get that, that's okay, but if you did, awesome. So let's go ahead and find the roots of this equation. All I'm going to do is factor. So let's see if we can. X times x. Well, 6 and 6 is not going to work. What else? Maybe 12 and 3. That's not going to work. How about 9 and 4? All right, so this should be 4x, and this would be 9x, but how do I add them up to get negative 5x? I need this to be negative, so this term should be negative, and this one is positive. And so I'm just going to rewrite it over here. X minus 9 equals 0, or x plus 4 equals 0. Add 9, x equals 9, or subtract 4, x equals negative 4. And those are the roots of my equation. In other words, the x-intercepts, in other words, where the parabola hits the x-axis. And so in this one, for example, I know this is opening up, and I know that it hits at 1, 2, 3, 4, 5, 6, 7, 8, 9, and at 1, 2, 3, 4. I know it hits there. I know it's opening up. I bet you some of you could guess how I'm going to find the vertex from this, but I'll leave that for another lesson. You have a rectangular vegetable garden in your backyard that measures 15 feet by 10 feet. Draw it. 15 by 10. You want to double the area of the garden by adding the same distance x to the length and the width of the garden. So let's start. We want to double the area. What was the area? The area, I'll just call it original, equals 15 times 10, or 150. So the area, when I double it, is going to be 2 times 150, or 300. How am I going to do that? I want to add the same distance x to the length and the width. So let's go ahead and add some x to both the length and the width. And so that will be my new dimensions. And so what is this whole length here? Well, it was originally 15, and now I added x. So this is just going to be 15 plus x. And what is this length here? Well, this was originally 10, and now I've added x to this side too. So that's going to be 10 plus x. So I now have that the area is 15 plus x times 10 plus x, and my goal is to make that equal to 300. Okay, now who is tempted to say, don't write this down, 15 plus x equals 300 or 10 plus x equals 300? If you're tempted, never do this. Okay, because we can only do that because of the zero product property. Only one or the other of the terms has to equal 0 if they're multiplied together to equal 0. So don't ever do this. Instead, what we have to do is first FOIL this side out. So we get 150 plus the outer is 15x, the inner is 10x, so that's plus 25x. Last is plus x squared. And now let's first set this guy equal to 0. So I'm just going to re-scramble this side so that it's in a normal order. And now I'm going to subtract 300. And now that I have it equal to 0, I'm going to try and factor this side. So now let me try and factor this. I'm going to just go over here. And I would get x and x. Let's see, 15 and 10, that would work except my signs wouldn't work, because if I had 15 and 10, in order to get positive 25, I would need plus and plus, but then that wouldn't work for that sign, so that's not going to work. But I could do 30 and 5. And so if I had a positive 30 and a negative 5, then that's going to work. And so that means that x plus 30 equals 0 or x minus 5 equals 0. So that would be x equals negative 30 or x equals 5. Could the distance be negative? No. So my only answer is x equals 5. But look back at the question. Find the value of x and then the new dimensions of the garden. So x equals 5 and the new dimensions of the garden are 10 plus 5, which is 15 feet, by 15 plus 5, which is 20 feet. And that's my final answer. Finally, we want to find the zeros of the function by rewriting the function in intercept form. So as I pointed out back here, the roots are like the x-intercepts. And so if this was a y equals equation, then I would have had my x-intercepts to plot. Oh, and I guess I really should have said that. This is the case that y equals x squared minus 5x minus 36. I don't want you to confuse a y equals with just a solving. If it's just a solving, we just get x values. But if I had y equals, like in this case, then that's what I want to do because I want to find the zeros. In other words, I want to make the y equal to 0, find the zeros. Let y equal 0. So I guess in this question they're asking us to first rewrite it in intercept form. So that would just be, let's factor this, and that would be intercept form because my intercepts are going to be hanging out for me. 28 is just 7 times 4, so I would need positive 7, negative 4. And so this is the equation in intercept form. And then to find the zeros, I just set that equal to 0. And I get x plus 7 equals 0, or x minus 4 equals 0, x equals negative 7, or x equals 4. So this is one answer, and this is another answer. And then let's just factor this guy. X and x, ooh, this looks pretty perfect. 2 and 2, minus and minus. You could write this as y equals x minus 2, the quantity squared. Either of these two answers are great. All right, and then we want to find the zeros, so I'm going to just write it like this. And so for our zeros, x minus 2 equals 0, or x minus 2 equals 0. Well, that's the same thing. I don't need to write it twice. Just x equals 2 is my only 0 in that equation. And that's it for this lesson.
Bye.